Hello everyone, I'm Amar Jamshed. So basically I'm going to be taking you through an entire series of lectures on what advanced data structures are or on what algorithms regurgitate around data structures. Okay, so everyone knows an algorithm is a sequence of steps. Data structures are particular formats or particular ways data has been generated. And if we look at right now, Stephen Hawking's book's example about how AI be destroying us or not. Okay, well, they all depend on how we use AI, and that depends on the algorithms and data structures of what AI is being programmed on. And we will be exploring those basics in detail in my series of lectures. So, look forward to having all of you. Hello. So, hello everyone. Welcome to my course on advanced algorithms and data structures and overview on them. And I will be using Python to train you within this particular niche skill set in computing and data. So before we start, I'd like to give a small introduction about myself. I am Amar Jamshed and I'm a data scientist, and I have been employed with AI Data Yard for nearly 2 years now almost, and I am a trainer with Simpliv and also a trainer at Institute of Bankers Pakistan in data sciences. So today I'm going to teach you the very raw ingredient that empowers this field, that is the algorithms and data structures. So let's start. So, definition and significance of algorithms, okay? They are an important sequence of steps to execute a computing task. Just like, we wake up in the morning and go to school as a task, right? These are the kind of basically steps the algorithm also follows inside computers just to execute one task, okay? Just like sending a link from one place to another, or sending a message from one application to another application, or from one website to another website. These are all powered by algorithms. So first we start with trees and graphs. There are two types of particular areas where I want to focus on, that is graphs. How these basically steps are visualized to us through edges. Basically edges are like lines connecting two dots, okay? And then there are binary trees. It's a hierarchical data structure, where each node has almost two children. So basically a node is a data point and a data connection, okay? And each node having two children, basically each node having two sub nodes, okay? So now let's see that in practicality with Visual Studio Code. Okay, now this is a binary search tree, okay? This is basically one algorithm of binary trees, okay? So it all comes under, in Python, there is something called a class. A class has multiple functions stored within it. So instead of us, individually calling each function, we can just call one class which will execute each function, okay? Just like an algorithmic process. Yep, they're also a type of algorithm as well. Programming is basically built on algorithms. Itself is a language to conduct algorithms, okay? So let me just copy this 1 minute. So this code, I'm basically using Visual Studio, okay? So Visual Studio Code is the most popular tool. You can also use, Jupyter Notebooks, enablement, what do we say? A Jupyter Notebook extension within Visual Studio, okay? Because Jupyter Notebook is the most friendly in terms of, conducting your coding and, checking your errors. So let's say if I run this node over here, shift enter, and now let's try another one, put a code tab, and let me paste what I was doing here. So let me check, I checked, set the root as none, I set values as a set, okay, of 20, 10, 35, 15. These are random values I just selected. Now for every value inside these values, insert a root, which is right now I've set as none, and then insert any random value from here. Now I basically told it that print and in order traversal. I've set that as a comment because you can see I've put that between two speech marks. And here, and then I have set the in order traversal function over here, which you can see I've set here under this entire class, okay? So I have basically set it as in order traversal and then root. So let's see what output it gives us. I've already given the comment of an output over here, which is going to give us 5, 10, 15, okay? Because it's setting us an entire order on a traversal method, okay? See, it's now given us the output of 5, 10, 15, 20. So this is basically how binary search trees work, where each node has two children and the values start from the left to the right, okay? they're read that way at least. So, and also, so that the left child's value is less than the parent's value and the right child's value is greater. So basically the left child's value has to be greater than the parent's value, and then the right child's value has to be greater than even that. You can see that over here, right? 5, 10, 15, 20, 30. It's legit given us, it's basically structured our data by smallest to largest, as you can see over here. Now, graphs, right? So, graphs, BFS and DFS. So, what do we understand by BFS and DFS? They are basically structures of graphs representing networks, okay? Okay, what's a social network? You know, one data point connected to multiple other data points, right? Like example, I'm connected to a friend on Facebook, right? That's one data point connected to another data point, and they are both backtracking methods, okay? So now you can see the difference between them, okay? Let's go that further. Now, advanced algorithms are sorting algorithms. You know, the one method we just saw over here was sort of a sorting algorithm as well, because the numbers were arranged in a particular order, okay? And searching algorithms like linear search, binary search, it's a sorting algorithm like I just showed you. It's sorting our data in a particular order, okay? Or our output in a particular order, like we see over here, okay? Now graphs, okay? Now you can see I created a class of graphs just like I created a class of tree nodes over here, okay? So definite, okay, now whenever I'm creating a graph, I first add an edge, you know, a connecting point from one dot to another, and then I add my method if I want a DFS or a BFS, okay? And then I basically have, okay, so I will basically decide first over here when I'm, you know, when I've created this entire class, I will run the class in a different method, okay, in a different area. So, okay, Python is case sensitive, so as you can see how Visual Studio Code is showing us the alignment has to be correct if you want to use Python. Now I'm creating a graph function over here, g equals to graph. As we can see, I have a class graph over here. So I'm directly importing the class here by setting it equals to g, and then I'm creating a random values for edges 0, 1, 0, 2, 1, 2, and then for every random value and second random value in the edges, add an edge that connects them, okay, that connects u to v. Now it will basically print a BFS and a DFS, okay? Now you'll get to know what they really are. So in BFS it's giving us 2031. From these random values it's giving us 2031, while in DFS it's giving us what? 2013. Okay, so now DFS and BFS, what are they? Okay, BFS stands for breadth first search tree, okay? I'll put that over here as well. Breadth first search tree. And DFS means depth first search tree. Okay, so breadth first basically, okay, when you release your breath on somebody, right? So it goes to the person that's closest to you, okay? So that's what breadth first does. It explores the closest neighbors, like, you know, what is the closest value to 2 over here? It is 0, it's shown. And okay, what is the closest value to later on, which is 3 and 1, okay? Because 1, it's basically common over here, right? And then 3 is very common over here, okay? So that's why it's chosen 2031. Now, in depth first search tree, it's showing us the values furthest apart than the closest ones. So 2013, while 2 is also very close, it's also the values that is most furthest apart from the starting one, okay? Take a look here and here. And then 1 over here, as you can say, also the most furthest apart over here as well, while also the closest. And then 3 again. So it's taking us the values with the largest distances and then merging them together. Okay. Now, after exploring that, sorting algorithms, including like the start of the entire lecture where we explored what algorithms are and the types of data. So now we are exploring basically So now we are exploring dynamic programming, okay? It's a method, where we divide, a bigger problem into smaller chunks and start exploring them one by one. Okay, in order to ensure our entire algorithm works. Okay, so now let's go to Visual Studio Code. Okay, so dynamic programming, as I even told you, it solves complex problems by breaking them down into simpler steps and storing the results of these subproblems to avoid computing the same thing multiple times. Okay, I don't want to example, process a transaction 100,000 times, right, just to find out if it's running correctly or not. It instead tries to find out what parts of the process are resulting in the transaction not to happen. Okay, so Fibonacci series, okay, this is one part of dynamic programming. Okay, basically returning the entire values in a Fibonacci set. Okay, and it's named after famous Italian mathematician. Okay, so now let's say in how Fibonacci works. Okay, let's take the number value and then the memo. Okay, any value we put in over here. So if the number in a memo set, return the memo in terms of return, basically transform them into Fibonacci and return the number set. And if the numbers are lesser than equals to 1, then return the numbers. Okay, and memo then equals Fibonacci n minus 1 memo plus Fibonacci n minus 2. So basically minus numbers by 1 and then add them by minusing the same number by 2 memo, and then return the full outcome. This is how Fibonacci works. Now watch, if I put 10 numbers, right, Fibonacci, and basically I put the function Fibonacci and put 10 as the parameter, it will return 55. So now people are asking, wait, how is it returning 55? You have to do the calculation to find out. 1 minus 1, 2 minus 1, 10 minus 1, 9 minus 1, it's returning the same thing. So now I'll basically now show you. So now add 10 plus 10 minus 1 plus, okay, plus, let's say now after 10 it's 9, 9 minus, okay, now the 9 minus 1, basically keep going like that, it will give you 55 total. Okay, and now the second part of dynamic programming, edit distance. So basically a way of quantifying how basically dissimilar two strings are, how different they are. It counts the minimum number of operations required to transform one string to another. Okay, so over here definition, like function of edit distance, we put two strings. Okay, it first calculates, look, m and n random values we've assigned both strings in the function, like calculation. So it takes out the length of string 1. If let's say my name Amar has, let's say, 5 letters, okay, and then Jamshed has 1 2 3, okay, 4 5 6 7 letters. Okay, it's taking account, okay, so it first calculates those numbers, and then take a look over here, it's plus n plus 1 multiplied by 0 for in range m plus 1. For every value in the string, it's going to find one value that's not similar. Okay, so for I in range m plus 1, okay, this is a bit of the extra garbage nonsense I'm not going to get into. Okay, but this, if you need to know that, look, for I we're starting a range over here, and if for j in range we're assigning for every random value in the range n plus 1. Okay, if I is equals to 0, then give us this value. If j is equals to 0, like every random value is equals to some value, give us these returns. It's basically a multi-function, okay, within a range. Now we are putting edit distance, and we put, let's say, kitten here and sitting over here. Okay, now it's giving us the value of 3. It's basically saying there are 3 letters that are not similar, that are not in both of the words together. Like example, in kitten, let's say we have K, we have S, and we have E, which are not present in both of the numbers together. Okay, because K is present in kitten but not present in S, and similar like that, E is present in kitten but not present in S, in sitting, and S is present in kitten but not present in, S is present in sitting but not present in kitten. The values which are same are I, T, 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 E, and then I, T, 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 I, and N in G. Okay, so this is what is shown us, that there are 3 dissimilar letters. Okay, and some people in this area will actually be confused, hey, but aren't there 4 letters that are not present from kitten and sitting? Basically that's exactly the opposite of what I'm actually trying to say. Okay, so kitten, basically, if I am to convert this value to sitting, how many letters will I have to change? Okay, so the ITT and ITT in and N in both of these words are there. So I have to replace S with K, okay, and then I have to replace, let's say, now let's see, I have to replace G with, let's say, I have to insert G at the end, okay, one letter extra, and I can replace E with I. Then kitten will turn into sitting. That's basically the amount of transformations I need to put to convert kitten to sitting. It's basically taking into account that if how dissimilar these two strings are and how the effort required to transform one word to another, just one string into another. Remember, that's what it said at the start too, how to transform one string into another over here. See? And we already talked about sorting. Like, it's basically from here we have random values, and then it's basically sorting it, the values, the smallest to the largest here, okay. And len array, let's say lesser than equals to 1, pivot, and then length, check the length, and then x for x and mirrored. So this is a lot of mumbo jumbo. As a person who needs to use this function, you don't need to know all of that, okay. This is basic math logic that we're pre-programming over here to start from the left to the right, okay, and creating a function.